We shall start in 1 minute. Okay, waiting for our host to conduct the meeting. Is Dr. Sayed here?
Yes, I'm
Okay,
here.
can we start now the session?
Yes. Give me a second, please.
Okay, please.
Good afternoon, ladies and gentlemen. We have the second session now. And I thank Dr. Vibhun Tepent for having agreed to chair the session. And Tepent, it's up to you. Please go ahead.
Okay, thank you, Dr. Sayed. Good afternoon, everybody. So in this afternoon, we will start the session of the renewable energy. Okay, the first paper entitled Modeling of Carbon Dioxide Emission on Dairy Farm Using ANN, a case study in Canterbury Province, New Zealand. So will be presented by Dr. Majid Safar. So you have about 14 minutes to present.
Thank you.
Please share your slide, please.
Thank you so much. May I share the... Okay.
Can you make it full screen, please?
Okay.
Okay.
Can you hear me well?
Yeah, thank you.
Okay, let me close the door because thank you so much for this opportunity. I really hope to meet everybody in the Nepal, but yeah, we lost this opportunity. I'm Majid from Lincoln University in New Zealand, and I work on energy management and CO2 emission, modeling energy management, CO2 emission in the last 20 years. This is part of one of my PhD student project, and we try to understand the dairy farming, energy consumption, and dairy farms in New Zealand, which is at the moment the main farming production in New Zealand. So we collected a lot of data and made a big database to understand the farming in New Zealand. And it's not very easy to interview farmers in New Zealand, but first I want to talk about New Zealand farming systems. In New Zealand, we have two different types of dairy farms. One, which is probably most of the farms that we would like that. We call it the pastoral dairy farming system or grass grazing system, which is quite unique in New Zealand. There are some in US or Ireland, but it's not very popular but around the world. But in New Zealand, the most common type of the dairy farming, that the cows are freely grazing around the farm. They move around and they have sections, paddocks, and every few days they move from one paddock to another paddock, and they move them. And nowadays there are a lot of projects to make it more efficient. There are virtual fencing. Virtual fencing has developed in New Zealand, and there are many studies to how we can manage this pastoral or grass grazing system more efficient. And another system I'm sure you would be more familiar is barn dairy farming system that keep the cows inside the barn. So one of this days, because of the mostly emission, the government started to encourage farmers to move from grass grazing system or pastoral system to the barn system. The main challenge is, as you can see in one of the images down, there are a lot of soil and water contamination. At the moment, almost there is no clean river in New Zealand. Everybody thinks New Zealand is a very clean country, but almost all lake and rivers are contaminated by nitrogen. So it's not recommended to drink any water from any river or even swimming in any river or lake in New Zealand. That's a quite environmental impact issue that we have. Another photo that you can see in the center, you can see there are some parts is greener than others. We call it urine patch. It covers around 18 to 20% of the surface of the paddock of the farm, and the cows urinate there. In some area, we have a high concentration of nitrogen. So it means when you are applying fertilizer, you are wasting in reality the fertilizer. But it makes a lot of, again, in terms of the global warming, climate change, water and soil contamination, all of them that make problem. But on the other side, when you have a barn system, you have controlled environment, you can collect the urine, manure, and manage the nitrogen and other things as well. So it was a very big challenge, a big question, which one worked better. So when we started to work on this project around a few years ago, everybody tell us, okay, the barn system would be more efficient and they have release less greenhouse gases and much cleaner. But when we studied, we found out the CO2 emission, the energy consumption in barn system actually is much higher than pastoral system. So that was the first alarming question that we raised. Okay, that's in many cases, yes, we know that we have a water and soil contamination, but on the other side, we have a challenge, which is about the energy consumption, CO2 emission, and we need to investigate it as well. So we have interviewed with around over 60 farmers around New Zealand. Around, I think, 15 or 20 of them are barn farmers, and the rest of that are pastoral farmers. Actually, we interview with most of the barn farmers. So when they have a result here, I cannot tell that's the average energy consumption in New Zealand because we is not distributed well, the barn and pastoral system well. So we interviewed around 20 barn farmers and 44 pastoral farmers around New Zealand. In New Zealand, the two islands, South Island, North Island, we interviewed in the both islands, and with the different size, we collected information. We try to, and one of my interests is investigating social, economical factor as well as the technical parameters. So we collected over 100 parameters and indices from the farmers, from the age, education, distance from the city, number of tractors, the size of the tractors, the number of the fertilizer application, average size of the section and paddocks, number of the cows, other production, number of the people who are working there, the age of the people who work. We look at if in the barn system, both actually most barn system, we look at the feeding ingredient and other parameters that they have. So when we look at it in the pastoral system, again, we find out the CO2 emission is less than the barn system. Again, many people think, okay, CO2 emission in the barn system would be more, barn system would be more efficient and there is less CO2 emission. But what we have found is the pastoral system, the CO2 emission is lower than the barn system. And actually, when we released the data first time, there was a lot of debate and question. It was, and it affected the New Zealand government policy later, because many farmers and New Zealand Farmers Federation used this data to show, okay, we cannot push farmers to change the farming system. It was really good news for farmers. And I met many people, many farmers that they knew me without me, they knew my name because they knew, okay, there are a lot of discussion about this project. So in the both sides, they are the main input parameters. I didn't put them in detail like fertilizer. We investigated lots of different fertilizer in the feeding supplement. Again, we collected a lot of more than 20 different supplements for machinery as well. But here we put them together. Again, I believe we cannot put them as an average because the number of the sample that we have is not distributed normally. So we try to collect, because there are not a lot of barn farm, we didn't collect, we try to collect them as much as possible. So we focus on them. So we have 20 barn farms, but pastoral, most of the farmers are pastoral farm, but we collected only 44 farmers. We try to collect them as much as possible. And that's a very important challenge. At the same time, we investigated data, we analyzed them based on the kg and based on the hectare. The kg actually here means the solid milk production. So it's 1.9 kilogram CO2 per 1 kg of solid milk, and for the pastoral system, and 2,857 for kg CO2 emission per hectare. So the kg over there is the solid milk or milk solid kg. So we are investigated based on the both parameters because it would be different. Some farms are more efficient than other farms, and per hectare, the number of the cows per hectare would be different based on the location, different the technology that they use. So that's the very important challenge, and we focus to collect the data as well. So to develop this project, actually, to understand it, we developed the two models. One is a neural network model and artificial neural network. At the same time, we developed the multiple linear regression model as well, compare the linear model and multiple neural networks. So out of them, I used for the logic to collect to optimize the samples. At the same time, we try to find the most efficient, most important parameters. The input variable shouldn't have the related together as much as possible. And if you work with the model, we have an input and output. We need to make the connection between the independent and dependent variable that we have. I spent a lot of time actually to develop this model to find out which variable can work better. At the same time, we need to, especially for the artificial neural network, you need to work on different model, different structures. You can make it usually we make a two layers model, but you can change the function and other parameters. So there are a lot of things that you can change and try. So making the model is mostly look like the art than science. So I started from the simple model and tried many complicated model, and I actually was really surprised. The best model we found out was the most simple one that we developed, the model with the two hidden layers. The first layer is the tangent function, and the second layer is the sigmoid layer. So it's two basic model, but we tried many complicated model as well. Lots of different functions, lots of different parameters change, but it works better than others. And the four variable that we choose, the farmer's age, number of cows, stocking rate. A stocking rate means the number of cows per hectare. That's the very important parameter in the pastoral systems. And electricity consumption per hectare, how much electricity they consume. Definitely in barn system, they consume much more electricity than pastoral systems. But in pastoral system, we have chance to be used more for irrigation. And one of the parameters irrigation in the part of the New Zealand, we have not a lot of irrigation system. In part of that, we have a lot of center pivot irrigation system and other system. Milking, that's another important parameter as well. So this is the model that we developed for by neural network. So it's for in the neural network and even model, any model, we have a training and validation. Usually we take around 15 to 20% of the data as a validation. So we develop the model and we test it by validation. I will show you the validation result as well. So you can see how is the model work well. We have it, R squared is 0.9. It means around 95% of the predicted and actual data matched together, which show how the model worked well. But we have a model for the multiple linear regression model as well. That's the for training, and you can see it's around 70% of the data predicted and actual data matched together. So that does show how a neural network can help us. The better modeling technique can help us, but still I've seen many people use the linear model. I use the linear model as well because it's very easy to explain it. It's very, even you can Excel, you can use it, and it's more understandable for people to understand it, to learn it and use it. But on the other side, in many cases, it cannot give you the result that you expected. So if you have a little bit complicated data, it's critical to use the more advanced data. I want to back to one of the slides, something I want to tell you. Based on my personal experience, actually, I try to put a lot of technical factor and social factor as well. Farmer's age is critical for us. We found farmers who are older, they consume much more energy than the younger farmers. That's another important achievement that we have. And it means the younger generation are much better manager on their farm. They understand the sustainability, they understand the technology, and they understand the new skills. So it helps them to manage their farm better. Many of the, and on farms, usually farmers are on average older than the rest of the society. So this is the validation data for neural network model that we have. So again, the validation delta is R squared. It's very similar to the training data, which is really good. It shows us the model work quite well. And after that, then we had, again, it makes a lot of discussion how we can predict the CO2 emission. The thing is still, you know better than me, again, it's too difficult to use these tools to teach or talk with or make a conversation with farmers. But for decision making for the government agency, it's much easier with this model to discuss any problem that we have and find out what's the best way to reduce the CO2 emission. In New Zealand, we have a plan to make the country as much as possible carbon free or something like that. And we are working on these topics a lot. So, and that's it. I have a lot of things to talk, but because my time is finished, I decide to stop it now. And again, thanks for the opportunity, and I'm ready if you have any question to answer.
Thank you, Dr. Safa, for your interesting presenter. So I think one question, quick question, please, from the participant.
One small question that thank you for presentation. Have you considered the density of the cow, like how many cow per hectare or per hectare? Have you considered?
Yeah, that was the stocking rate.
Yeah. Okay.
The stocking rate is number of the cows per hectare.
Okay.
Okay. In the barn system, they keep, again, they have a different system. We have not one barn system. Some of them just keep the cow inside the barn. But we have no barn system, no barn farm in New Zealand that farmers only have barn. All of them, they have farm and they have a housing for the cows as well. So they use that sometimes when they let them to go and freely walk out, but they use that farm to produce the pasture and grain and some as well. But stocking rate, it means the number of the cows per hectare.
Okay. Thank you again, Dr. Safa. Shall we move to the second paper? The paper, the second paper entitled Effect of Pretreatments and Performance of Hybrid Solar Dryer on Drying Moringa Leaf in Bangladesh will be presented by Dr. Saha. Dr. Saha, please share your screen in full mode, please. Thank you. Okay. The floor is yours.
Yeah, thank you. Good afternoon. Thank you, Chair, Co-Chair, and participants. I'm Chawan Kumar Shah, Professor of the Department of Pump Power Machinery, Bangladesh Agricultural University. I mostly work on the renewable energy-based technology, uh, like solar and biogas-based technology. So my presentation title is Effect of Pretreatments and Performance of hybrid solar dryer on drying moringa leaves in Bangladesh. And I'm presenting on behalf of my team. And you know that moringa is an underutilized perennial tree species indigenous to the South-Himalayan tract of India, Bangladesh, Afghanistan, and Pakistan. But it is very well known for high nutrient content, including vitamin, mineral, and antioxidants. These moringa leaves we can utilize for cooking, drying, or grinding into a powder. And most convenient and commercially way would be for drying this moringa leaf using the dryer. Uh, but we have this, but there's the issue of natural convection dryer that we need sun. If there is no sun, we cannot dry it. So that means in that case, the hybrid option of drying could be a better solution for smallholder farmers to minimize food waste and prevent the problem associated with the normal sun drying. And however, defined pre-treatment of drying moringa leaves could improve the quality of dried mango. Therefore, the objective of this study was to assess the technical performance of BioADI hybrid solar dryer for drying moringa leaves. This dryer has been developed by Bangladesh Agricultural University in collaboration with Agromet Development Initiative. And another objective was to investigate the effect of defined pre-treatment on dried moringa leaf through color analysis. This is the dryer which has been developed. It's a multi-layer double chamber dryer. It's a hybrid node dryer, solar and electric hybrid system. So when there is no sun, the electric heater can be turned on and then provide the hot air inside the dryer. And also there is a IoT-based monitoring and controlling system. And as you can see with this dryer, we can maintain temperature 45 to 60 degrees C even without sunshine. And in the dryer, you can see the dryer mostly based on that. Actually, we mostly rely on the sunshine hour, and we strap actually solar radiation inside the dryer and warm up the air. But if there is no sun, then you can see in the bottom part there is a heater, so which turned on and then provide the hot air. And if there is a temperature above recommended temperature, there is an exhaust fan which can actually take out the hot air if required. And dryer, actually, we have tested this for moringa leaf, but this dryer actually is a multi-purpose dryer which can be used for drying fruit, vegetables, spices, and fish as well. For doing this experiment, what we have done actually, we have collected the samples and sorted out and washed out and then dripped out into the water. And we pre-treated with a full defined pre-treatment. You can see that only the blanching for 2 minutes and then blanching and immersion in 0.5% KMS solution. And another pre-treatment was blanching and 0.1% sodium bicarbonate and 1% magnesium oxide. And there was a control where the sample we didn't do any pre-treatment. And then we put into the tray and dried it in the dryer. And also we put also sample in outside in the open sun. So we compared those two options with inside the dryer and outside the dryer, it's in the open sun. And we, for doing that experiment, we have used actually 12 thermocouple sensor for monitoring the temperature in different location of the dryer. Also we used a relative humidity sensor and also solar radiation measuring of that we put outside the dryer to monitor the solar radiation. So the idea was to check the solar radiation input on the inside the drying temperature compared to ambient one. And if we look at the solar radiation, when there was a high solar radiation, of course, the temperature was high and also relative humidity is lower. But when there is no sunshine or the less solar radiation, then temperature reduce and relative humidity increase over the time. If we look at the temperature difference between in and outside, there is a significant improvement of drying temperature inside the dryer when there is sun. Of course, you can see the variation, which actually vary due to the time of the day during the drying. And we can see the clear difference from ambient temperature to the inside the temperature is actually 13 to 17 degree on average. If we look at the moisture removal, moisture content, and you can see that the drying was quite faster initially, and then in the hybrid solar dryer, moringa leaves can be dried in a day, but for the open sun time, it took even 2 days to complete the drying or reach the desired moisture content. If we look at that drying time, so for in the hybrid solar dryer, it on an average took 6.5 hours, but for that actually hybrid third trial, there was a little bit issue of rain, so that's why you can see there is a high drying temperature. And in an average drying rate it was around 10% in the dryer and then less in the open sun drying. The drying efficiency was around 15.73, but things actually depends on the loading amount that you are giving inside the dryer. So amount of dried product is quite important in increasing the efficiency of dryer because we are using the same size of dryer for different size of sample. If we look at the color quality, we can it is a color coordinate value of first moringa leaves and the drying moringa leaf powder. We can see that the KMS solution provide quite a good color acceptability and the color intensity compared to the other sample. Of course, the control one also had a good color complexity. So in conclusion, we can say that the both KMS or the control one can be used for drying the moringa leaves inside the dryer. So in conclusion, I'd like to say that dryer provide the better drying condition with the higher temperature or the temperature that's required for drying the moringa leaves, and the time also reduced. In a day, we could dry the moringa leaves, and the product quality is quite good, which preserve the color intensity, which is very important. and there is the option for live monitoring and control. So we could control the temperature and the heater remotely. And I could say that this is a farmer-friendly option for drying any perishable products. Of course, I have presented here only the moringa leaf, but we have tested for other fruits and vegetables, even fishes. The dry could give quite a good results. Uh, so we are happy that that farmer friendly dryer can be used in the real field. So uh, I would like to acknowledge the Mercantile Bank PLC actually who was the principal donor of this project, of the research project, and then Alma Mater Bangladesh Agriculture University for supporting us, and then Agromet Development Initiative is a private sector partner for providing the technical collaboration. So thank you very much for patience hearing.
Thank you,
I
Dr.
stop here.
Thank you, Dr. Saha. So the floor is open for question. We still have time, about 5 minutes. Please. If not, I start the first question. So is your recommendation for the pre-treatment, whether 1 or 2 or 3 for the good result?
Sorry, actually, I stopped this sharing, but we recommend that that the only the control, only the washing and cleaning can be used for drying the moringa leaf, but better would be if we use 0.5% KMS solution and blanching method, then the product quality is much better, and you can preserve it a longer period. We also tested keeping in the defined packaging material, and we found that KMS solution blanching one provided a very good result. So,
Okay. You should consider for the economic also, for the cost of dyeing when compared to the
yeah,
solar.
yeah. Of course, the financial issue is very important, but in this case, we didn't calculate the actually the financial. We didn't do the financial analysis, but in a nutshell, I would like to say that we have did the financial analysis, and what I said, this is a multi-purpose dryer, so it can be used year round, and we have found that the payback period is 2 years. So within 2 years, you can get back the money. So if you invest in for this dryer.
Okay.
So,
Other question from Dr. Indra Mani.
yeah. What
please.
extent this moringa leaf is commercially exploited in
Yeah,
your?
it actually in the actually pharmaceutical company they are using it, and also many people nowadays they're actually using for their diabetics and other uh, issue as a they actually drink is as a juice. So there is a not that big market, but there is a demand of these moringa leaves in the pharmaceutical company as well as uh, in the some health or people. So it's now popularizing in Bangladesh.
Okay. It cannot come as a cottage industry, processing cottage industry with your dryer.
Yes, that's possible. But what we are doing through our project, actually, we are engaging the community farmers. So what they are doing, they are drying it and packing it for local selling of like potato chips, also the mango leather, as well as this moringa and all things. So they are set up in the tribal area as well as in the highly dense fruits and vegetables growing area.
Yes, because in India it is very commonly used in the different parts of the country. And
Right.
As a household item.
Right.
Great.
Oh, okay. Thank you, Dr. Saha. So shall we move to the next paper?
Yeah.
Okay.
So the next paper entitled Microplastic Pollution on Agriculture, Sources, Risks, and Mitigation Strategies will be presented by Dr. Chama. Dr. Chama, please share your screen
Sir,
in full mode.
Dr. Sharma.
I'm trying to share the slide.
So you will have about 14 minutes for your presentation.
I request the presenters to give a very brief introduction by yourself because we do not have that much information about you. So we'll be happy if you can.
Sir, because of, sorry, sir, I have to quit and join again because of my permission to my MacBook.
No problem.
Sorry for inconvenience.
No problem.
So are you ready?
Dr. Sharma, unmute. Yeah.
Sorry, sir.
Now you continue.
Okay, let's start.
Sorry. My name is Prabhakar Sharma. I'm working at the Department of Agriculture, Engineering and Technology in the Soil and Water Engineering specialization at Nagaland University. Today, I will be talking about the microplastic pollution in agriculture. I will be covering different sources as well as their
We
path.
cannot see the presentation you're presenting.
Okay. Can you see, sir?
No, we see the other page. You have to open your PowerPoint and share.
Okay. Maybe I'll share the entire screen.
Okay, this is fine.
Okay, sir. So I'll try to make up this time. The outline of today's presentation is that I will be covering, starting with some of the extent of microplastic or plastic in general in agriculture, their sources. Then I'll try to define very briefly the microplastic and their pathways, and then their impact on soil and plant, as it is the interest for our probably the conference. And at the end, I will also have some health risk due to microplastic and then try to propose some mitigation measures. So as we see in this slide here, there are a number of tools and things which are being made of plastic, and that is very commonly being used in agricultural sector. So if I see some global picture by 2020, it was already 367 million tons of plastic being produced globally. And out of that, almost 3% have a share in agriculture sector. Of course, they persist in soil, in addition to the aquatic and atmospheric system as well. So some of the sources, like especially if I focus the agriculture, the major contributing factor coming from the mulching, the plastic mulch which we used in agriculture, they are almost like 40%. And then sludge and compost have also a good share in addition to the other sector in agriculture. So if I see some of their unique properties, why plastics are being commonly used in agriculture or in other sector. So it is, of course, non-biodegradable. So it's good for the many product. Because of their density, it may easily float on the water surface and have a very high mechanical strength. They can easily migrate through the environment and eventually can end up in the soil, or if I have a neighboring water like river, pond, or ultimately to the ocean. So there are a wide variety of anthropogenic items made of like a bag, bottles, or other, which I just mentioned in agriculture sector, and they are creating the problem. And it's not only the problem for agriculture, ultimately they can be problematic for animals, plant, as well as the human life, which I will be discussing some of them. Now coming to the microplastic, why it is different than and how it is different than the plastic, just because of their sizes. So this microplastic, it is being defined by the scientist, any plastic which is less than 5 millimeter in size and above 1 micrometer. And if it is smaller, then we can call them nanoplastic. In terms of the type and shape of the microplastic, they are having two types. Basically, we can categorize them into primary microplastic as well as secondary microplastic based on their source, like those which are already exist in those sizes in different product. In the microplastic sizes, we are calling them microplastic. And if they are coming after their disintegration or after they are forming into smaller sizes, then we can call them secondary microplastic. These are some of the examples which we can see are present in many different product, like fiber, for example, coming from the washing machine or other sector, foam, fragments, film, as well as the beads. For example, micro beads are being used directly in the cosmetics and other product. Of course, they also have use in agriculture. If I focus more on the agriculture, what would be the possible pathways or major method of coming into the agriculture or soil? As I also mentioned about the plastic, that means sludge and compost are including like plastic mulching are the major contributing sector even for microplastic. In addition, there are a number of irrigation equipments like drip line or other plastic materials which are being used. They also disintegrate in the sunlight or other way of converting into smaller sizes and pollute the soil and agriculture. In addition, they also are being aided with some of the like fertilizer or compost or other seed manipulation also being done to enhance their properties, and that is contributing to the microplastic pollution in agriculture. Now our interest is like how they are affecting the soil. So if I see this graph, which is one of the study I found interesting, is like some of the soil properties like porosity, bulk density, hydraulic conductivity, how they are changing. So it's natural that like a bulk density, because density of plastic or microplastic are smaller than soil. So density are certainly will decrease by aiding or having the microplastic in soil. Similarly, porosity also decreases. Hydroconductivity has also some impact, but interesting thing in this figure we see there are a lot of variation. So basically it can be either case to case basis, it may affect directly, indirectly, but not like significantly having any consistent trend, which I try to see in other sector. For example, in this figure, if I see by dividing them physical and biological properties, some of the common physical, chemical properties are here in this left-hand side. So it says that it concludes that it's not consistent. So for example, pH. So not necessarily the pH will only increase if I having the microplastic in soil. So it works in both directions. So it may decrease, increase. So a lot of variation. So similarly for microbes and plants, animal, or other properties which I found interestingly not having consistent trend. I try to see in this picture again by having some particular type of plastic material or microplastic contributing materials, and then see in some of the parameters like bulk density. Bulk density certainly decrease irrespective of the plastic types, but let us see the water holding capacity. So yes, for polyester, if there microplastic are there, then it may increase. But again, if I have other type of plastic polymers which contribute as a microplastic, maybe there is no clear trend. And it is true for other soil properties as well. So this is the issue here. Still, like there is a gap and need to be deal with the case-to-case basis, or the type of polymers also play a role. Not only type, their sizes, their shapes are also important. Another one, if I study, I saw that in the nutrients specifically, here there is at least a clear trend that nutrients are having some reduction after having. So somehow at least this is clear that although they may not have a consistent trend in changing the soil properties, but the productivity may reduce as we see in the nutrients. So now I try to see like how they are affecting the plant. Then it was very clear that microplastic may enter to the roots, which is very commonly it's inside the soil. So that might be the primary target. Of course, the other part also may come into contact of microplastic, but here that is the major method of interaction of microplastic. Then some of the mechanisms also involved, like adhesion, for example. So they may attach to their surface of the plant by certain mechanism because of their smaller sizes in nature, and ultimately may translocate through the plant xylem and reach to the leaves as well. So entry can also occur through stomatal pores in leaves or cracks in the plant tissues, especially if they are in smaller sizes, like specifically the nanoplastic, which are more linked to this impact. After that, I try to touch upon the connecting the food security and human health risk. Then this cartoon image has some indication like microplastic contamination in food crops may undermine the food safety, which is very obvious, and ultimately can pose some risk to the health, which if we are consuming as a human or animal, if they are consuming. So it is ultimately going into the food chain and threatening the food security, particularly can be vulnerable for the people or the particular who are dependent on agriculture. Now, some direct health impact. There are a lot of studies, so I just have one summary here who particularly work on the health impact. So people are basically constantly exposed to microplastic via food, water, air, or other consumer products. So sometimes can cause even the cancer, lung or cardiovascular diseases, or impact some of the immune system like liver, neurological system via different way, like either it can be if somebody ingesting it through some source or even by inhalation. It's if it is present in the air or dermal contact. But if I see this flow chart, it's very interesting, although it looks complicated, but I just wanted to show that the food is not only the source of microplastic, which are impacting the health. There are many other like cosmetic products, clothing industry, medicines also may have plastic or even through air like a dust. So a number of exposure pathway can happen other than food system. So yes, food is one of them because it directly ingests and goes to the intestine, but there are some other sources. Then the last thing I wanted also to mention here, the mitigation measures. What are the possible one? So there are a number of strategies which includes the eco-friendly restoration method like phytoremediation, remediation, or even some of the recent one which I have been working on biochar application of removal of microplastic. Of course, I had been doing more on aquatic system, but it may be also applied to the soil and agriculture through number of ways. So some policy reform or can be applied to reduce the plastic use or even biodegradable plastic alternative is also being proposed these days, or even require some bigger stakeholder collaboration. So agroecological technique like crop rotation or even replacing the chemical fertilizer with organic fertilizer may also mitigate the microplastic impact. So this is more specific to the one of the method which I had tried to look, and although it is more applicable to aquatic system, but I thought there are a number of ways which are available to remediate or reduce the microplastic content. But I had focused more on adsorption technique. And there are a number of adsorbents which can be used like carbon nanotubes, activated carbon, or as I said, the biochar application, which is one of the more economical and better way of reducing the microplastic content, which can also be used in agriculture by adsorbing or segregating from plant, not to take from the soil. So that method can be used. So if I conclude my talks, then microplastic has increasingly threatened the ecological stability and food security by impacting the plant health as well as soil microbes, while it is presenting a significant risk to the human health. So microplastic threaten the ecological stability, plant and soil health, as well as the food safety. So the major challenges are lacking the standardized detection. So it all depends on the researcher or the places where it is being detected. So some standardization is required as it is being proposed for aquatic systems. So if done in agriculture or in the uptake of plant, that might also be helpful. At the end, like policy reforms and interdisciplinary collaborations might be very crucial to promote the sustainable plastic waste management across the globe. So with this, I just want to thank you. I will be happy to answer any question.
So thank you very much, Dr. Sharma. Very interesting topic. So we run out of time. So I think we have no question on this topic. Shall we move to the next paper? So
Thank you, sir.
the fourth paper entitled Smart Ship Plus Approaching to Downstream Energy Utilization from Solar Irrigation Pumps in Bangladesh will be presented by Dr. Shah again. Please, you have about 14 minutes.
Yeah, thank you very much. Uh, Actually, it's really nice to present in this international and large audience gathering. Unfortunately, we are online, but anyway, it's a good platform to share our ideas and research. So, my topic is you see the Smart Ship Plus that approaches to downstream energy utilization from solar irrigation pumps in
I cannot hear you. Low. Please turn on your mic. Okay.
Sorry, probably the power internet connection was not stable. So
Okay.
can you hear me and see my slide?
Yeah, clear now.
So what I'm saying that I'll give some context of the research and then objectives and what are the methods that we are going to follow and some of the initial results and that expected outcome from this research I'll share with all. You know that Bangladesh is ranked 7th in global climate risk index, and we are using say 6 million irrigation farms for irrigating land, and out of them 1.2 million tube powered by diesel engine, which actually consuming 1 million tons of imported diesel and emitting 3 million tons of CO2. So replacement of diesel pump with solar irrigation pump would provide a critical role to reliable distribution of clean energy, and that would help reconcile production and environmental goals. Keeping that in mind, actually our government unveils new renewable energy policy where actually our government said 20% of power demand from the irrigation should come from the renewable energy source, especially solar by 2030. And you can see because of that favorable policy, there is a huge boost up of solar-based irrigation farm from 2020, and it was 158 in 2020, and it boost up nowadays is around more than 3,000 solar irrigation farm. But if we look at the season-wise or month-wise irrigation pump use, you could see that from December to April, there, especially in December, January, the people doesn't use that much of solar. But in May, June time, there is a huge use. But on the other hand, in June and July, you can see again the utilization of solar system for irrigation is less. And average day hours during the actually off-peak time is around 1 to 2 hours they can use the solar irrigation pump, but rest of the time is sitting idle. But in peak paddy season, of course, they're using 7 to 9 hours. And you can see we are growing three rice, Aush, Amon, and Boro rice. And Boro, especially from November to February, in March, April also, that mostly we are using actually groundwater for irrigating our land. And you can see that use of number of use of irrigation per season is 21, is in the especially in the Boro rice. Also, we use irrigate vegetable production land also with the solar irrigation system. On the other hand, if we look at our vegetable production, we are producing huge amount of vegetables, fruits and vegetables, around 17 million ton per year. But we have also huge post-harvest loss around 25 to 40%. So this loss can be reduced by utilizing actually cold storage or different processing option like drying, as I presented earlier, or milling or something. But all of those actually uses require energy. And in this path, actually, could see there is a clear bonding between the solar irrigation system and then there's machinery use. So there is an opportunity to leverage this excess electricity from solar irrigation farm and utilize it locally and smartly to support agricultural and rural communities. With this, actually, we have recently funded by the UK government, and where we are working on to drive forward a large-scale clean energy transition in rural communities of Bangladesh through design and development and demonstration of smart energy system, which exploits the excess solar electricity from the solar irrigation farms. So that means we are actually going to use the underutilized energy from the solar system, solar irrigation system for other purposes. You can see that this is a kind of vision that we have, that we initially in the small circle, we would like to use with the solar irrigation system, the small cooling system, cold storage. And then we have envisioned to use excess energy for processing like drying, milling, grinding, etc. And if there is excess energy, more excess energy or no utilization for other purpose, then that can be used for actually charging the electric vehicle or electric machinery, as well as can be used for producing pure drinking water. In some part of the country, we have a problem of arsenic and other contaminant problem in the irrigation, in the drinking water. So that can be utilized for producing pure drinking water. And we have also planned to make a hybrid system, solar and biogas. So in some one point, we would like to test that one also. So to achieve that goal, actually, we are using the hub and spoke model, and our university, Bangladesh Agriculture University, that will be the main hub, smart seed, where we are going to test the system and develop decision support tool, and that can be actually will be piloted in different locations of Bangladesh, as you see in the map. For actually validating our location, that we had did some GIS mapping analysis. Would like to wanted to see that where most of the seats are located, and you can see that there are 3,439 seats located in different locations in Bangladesh, and most seats are located in northern and southeast part of Bangladesh, and then southern coastal belt and southern eastern hill region has least intensity of solar irrigation farms. And if we look at the heat map, you can see the density, the northern district like Thakurga, Dinajpur, Nauga, Bugura, these are the densely populated, like densely sheep area. And then other part is not that much. So our actually 3 field locations are located in the intensive district where sheep are mostly propagated. And if we look at the actually the key player of this installation of SIP system, there are many agencies and the institute they have installed this SIP system around Bangladesh. There is a automation company.
You lost signal again. Hello, Dr. Saha. Maybe no signal. So I don't see. Come. So please continue your presentation, Dr. Saha. No,
Dr. Saha,
maybe the internet is not good.
who is the next presenter?
So what shall we do? We move to the next.
Yeah.
Dr. Saha, are you here?
I'm really sorry. I don't know. I have having the internet issue, but it's disrupting. I will finish quickly my presentation. So
So would you please conclude your paper?
yeah. Thank you. So the things actually, what I'm saying that we would like to actually see the community agency-based surface water irrigation system and see the model of also community agency-based groundwater irrigation system, also individual on groundwater irrigation system. And we want to see the business model, the ownership model and fee for service model. And at the same time, we are using actually top down and bottom up approach for achieving the goals. And you can see some of the locations of our view smart hub. And this will be our actually the smart hub for solar multi-purpose solar irrigation system. And also some sites you can see the Bhaluka site close to Mymensingh, also in the Kustia side, and also Chuadanga and the Dinajpur side where we are going to utilize this already existed solar irrigation system for multi-purpose use, utilizing excess energy to operating cold storage and also the dryer and process industry like milling and drying, etc. So, and to do that, actually, we are going to develop a decision support tool and we would like to optimize smart grid, mini grid system with focus on the efficient operating management through introduction of digital twin. And also we are going to analyze different business model and assess this business model and recommend the business model for viable solution. And we'd like to empower women and marginalized group by reducing drudgery of tasks through using the smart system. And also we'd like to actually increase the entrepreneurship by improving the access to energy. So this is the, I would like to acknowledge UK Research Innovation Fund providing this funding to do the research, and Birmingham City University for the collaboration. And there are two private sector partner, Bright Grid Energy Foundation and Water Sanitation for Urban Population for the collaboration. So thank you very much for giving me the opportunity. I'm really sorry for the interruption. Yeah, because of the internet connection, I could not actually present smoothly. So thank you very much.
Thank you very much, Dr. Saha. So I think one quick question, please.
Please.
Okay. If none, thank you again, Dr. Saha. So
Thank you very much.
shall we move to the next paper? So the next paper will be entitled Efficiency Evaluation of Lead and Copper Removal from Mona River Water. Acola using low-cost agricultural absorbent will be presented by Dr. Taloka. Please. Is Dr. Taloka here?
Who has to present?
Ooh.
Doctor?
Paper number RE08. Nobody? From India?
Yeah, they will not be joining today. Maybe they are all traveling.
So they have requested for tomorrow, eh?
Yes, sir.
Okay.
They are
So
all returning by road.
so we move
Go to the next speaker.
We move to the next paper. So the next paper, number 09, is the presenter here?
Yes, I am here only.
Okay,
Yes.
okay. The paper entitled Mechanized Strip Cropping Pattern for Assessing Production Efficiency, Energy Requirement, and Yield Attribute Come Economics in Soybean
Hello.
and Pigeon
Hello,
pea
Sridhar. Welcome.
intercropping.
Okay.
So please. Okay, the floor is yours. Please share your PowerPoint on full screen mode.
Yes, sir, I am sharing. Yes, just.
And you have about 14 minutes. Né?
Yeah, yes.
Okay.
Yes. Sharing करेगा Sharing
You
करेगा
open and PowerPoint in full screen mode and then share.
Sharing. Is it visible?
You click
Yeah, it
full
is
screen.
visible.
Make it full screen mode,
Full screen.
please.
Full screen.
Data Saver, make it full screen mode.
Yes, sir. That's only I am doing. Full screen. Yeah, sir. It is okay, sir.
Okay.
Yeah, good afternoon to all. Chairman of the today's international conference organized by AAAE, and this is on the climate resilient agriculture for the Asia 2025. And myself, Dr. Bhagwan Asewar, working as a Director of Instruction and Dean, Vasantrao Naik, Marathwada Agriculture University, Parvani. I have the experience of 20 years of the working in this university in different capacities as a SRA, then junior agronomist, senior agronomist, as well as chief scientist of the dryland agriculture. Then I have worked in the NICRA project of CREDA as well as POCRA project on the climate resilient agriculture in Maharashtra. Also work as a professor of agronomy as well as the head department of agronomy as well as the director of extension education in Vasantrao Naik Marathwada Agriculture University under the able leadership of our Honorable Vice Chancellor Professor Indramani sir. And my topic of presentation is the mechanized strip cropping pattern for assessing the production efficiency, energy requirement, and the yield attributes from economics in the soybean and pigeon pea strip cropping. We know that the soybean and pigeon pea, these are the major crops of the all over India, world as well as India. And in India, this soybean crop is grown on more than 100 lakh hectares area, as well as the pigeon pea is also major crops in India. And the flow of my presentation will be the introduction, objective, methodology, as well as results and conclusion. So as I have told that this strip cropping is very important. As these are the two major crops grown in the Marathwada as well as Maharashtra and India. Those are the pulses, and the farmers, they are not taking much in the intercropping system because due to the less machinery available with the farmer. That's why this strip cropping is having very much importance in the this region to protect the soil from the wind and water erosion as well as the reduce the mineral leaching losses also. And we know that the well-managed mechanized strip cropping system could result in the higher profitability and helps toward the minimizing the energy requirement. That's why this experiment was planned on the dryland research station during 2019 and 20. So the objective of this projects were to study the various strip cropping for soybean and pigeon pea crops under the mechanization. As already Honorable Vice Chancellor Professor Indramani sir in the morning keynote address, he told that we are having the seed-to-seed mechanization in this pigeon pea as well as soybean. And the second objective is to find out the suitable ratio for soybean and pigeon pea strip cropping under mechanization, to study the economics feasibility of the treatments under the mechanization, and to determine the energy requirement mechanized strip cropping. So these are the treatment details. There are 8 treatments are there in different row ratios of the soybean as well as pigeon pea. Here 60 is to 3, 6 is to 3, 6, then 12 is to 9, as well as 12 is to 12 rows, and to 18 is to 12 rows, and the intercropping which was already recommended for this region, that is the soybean plus pigeon pea intercrop system, also one of the treatment for the control. And we have taken two sole crop, that is soybean and pigeon pea. So this is the experiment details, whatever the varieties we have chosen for this experiment. That soybean we have taken the MUS 162, which is the very climate resilient variety, as well as in pigeon pea also this BDN 71. It is also climate resilient terminal drought resistant variety, which is developed by our university. Both the university varieties were developed by our university. We have taken 3 replication designs, RVD, and variable plot size with spacing of 45 centimeter in soybean and 90 centimeter in case of pigeon pea. So these are the results. So here we can see the plant height is also higher in case of the treatment T5 and T7, as it is sole crop, and the T5 treatment is the soybean pigeon pea 18 is to 12 rows. And in case of this, we are having in this slide that the dry weight. So the all the parameter dry weight as well as plant height is more in this soybean plus pigeon pea 18 is to 12 rows of the soybean and PGNP strip cropping. As this soybean as PGNP is major crop, and that's why we have taken these treatments with the control treatment. Here we can see the mean leaf area. Also, it is also more in this treatment T5 as well as the T7. Then we have taken the observations on different aspects, also parameters which are yield attributing parameters are also there. So can see the periodically we have taken the observation, and it is found that in all the treatment means T5 as well as T3, that is 12:9 and 18:12 rows of the soybean and PGP has given the higher yield attributes also. So here we can have the yield attributes in case of the soybean. So weight of pod per plant, number of seed per plant, seeds per plant, as well as test weight. It is higher in this treatment T3, T2 and T4 as compared to the sole soybean. Here is also the seed yield attributes in case of the pigeon P are given, and the same results are likewise in treatment T5 as well as T4. They are giving the higher percentage of this weight of per plants, number of seeds and weight per seed and test weight. So this is the full analysis in case of the seed yield. In soybean, we can see that the higher seed yield was observed in case of this sole soybean. After that, the treatment, that is soybean plus PGNP 18 to 12 rows. This is about the PGNP attributes. So here also we can see that in case of the PGNP, the height, plant height and dry matter was also more in case of this ratio, tree cropping ratio in the soybean PGNP. In case of dry matter in 1920 also it is given. Then mean leaf area, here also it is more. Number of it, here also it is more. And we can see the intercropping system, strip cropping system. As compared to intercropping system, strip cropping has given the higher yields in case of 18:12 rows. Here is the yield attribute parameters in the pigeon P, weight of plants as well as the number of seeds per plant, weight of seeds per plant as well as the seed weight and test weight per 100 seed of the 1000 seed of the pigeon P. It is also more in this treatment. These are the yield attributing parameters. Here is the main seed yield. Seed yield during the 2 years of experimentation as well as in the pooled mean, and it is seen that it is more, it is higher in this 18:12 rows of the soybean and PGNP. This is the seed equivalent, soybean equivalent yield during the period of experimentation, and here also you can see as compared to the sole pigeon P, it is higher in the 18:12 rows of this strip cropping in soybean and pigeon P. The gross monthly returns as well as the net monthly returns were also higher in case of this uh, strip cropping, that is soybean plus is to pigeon P 18 is to 12 rows. BC ratio is also higher as compared to the sole crop. The maximum was observed in the sole pigeon P, but after that it is in soybean plus pigeon P 18 to 12 rows. This is also the data, pooled data about this strip cropping, and here also you can see the major T5 treatment has given the higher uh, yield in this particular treatment. Economic efficiency, the rupees per hectare per day, it is also higher in case of soybean plus pigeon P 18:2 as compared to the others, so like soybean as well as other treatments of strip cropping. Then in case of the rain-fed areas, because our is a very hot spot of the dry spell as well as the drought, and we are experiencing many droughts, lots of droughts in 1970, also before and after that in 2014 and 15, as well as 18 and 19, also some droughts were there. And under this, the water use efficiency is also very important, and we can see here that our area is having frequencies of the dry spells are increasing, and that's why the production is declining. And under this situation, the strip cropping, that is soybean plus PGNP 18:12, has given the higher rainwater use efficiency as compared to other strip cropping. Then land equivalent ratio land equivalent ratio is also very important, and it is the highest land equivalent ratio in case of this 18:12 rows of this strip cropping. Area time equivalent ratio is also higher, as well as the land use efficiency is also higher, in particular this treatment. That is the soybean plus PGNP 18:12 strip cropping. Then, in case of this, what are the processes for adapted for the energy requirement? Here, the formulas are given, and on that basis, we have estimated the energy requirement, and these are the consideration values for different parameters. Here is the energy requirement as per the treatments wise. We have estimated the energy requirement, and we can see that here, in case of this sole as well as sole pigeon pea soybean, we are getting higher energy requirement, less requirement of the energy in case of soybean and pigeon pea, that is 18:12 rows. Here 2080 only required as compared to other treatments of this strip cropping. So that's why the energy consumption rate was found highest in T7 as most direct and indirect energy involved due to the higher consumption of operational time of the seed drill and other fuels. Here is this is the consideration for energy requirement for the combine harvester, because we have used this class combine harvester for harvesting this soybean as well as pigeon pea crop. And this is the energy requirement for this combine harvester. These are some of the photographs at the time of harvesting with this combine harvester in case of soybean as well as pigeon pea. And the conclusion is that among all the treatment, the sole pigeon pea recorded highest soybean equivalent yield, land equivalent ratio, production efficiency, as well as economical efficiency, as well as ATER. And it was followed by soybean plus pigeon pea strip cropping is of 18:12 rows. And the highest GMR as well as NMR also given in case of the soybean plus pigeon pea strip cropping, that is 18:12 rows of the strip cropping. Then the energy consumption rate was found less in sole cropping of the pigeon pea sowing, as well as highest in the sole cropping sowing of the soybean crop. And the energy requirement in the treatment T4 and T5, that was the treatments 12:9 as well as 18:12 strip cropping ratio was found nearly same, along with the better results of the crop yield attributes in the same plots. And that's why it is found that among all the strip cropping treatment, T5, that is soybean plus pigeon pea strip cropping, 18:12 rows recorded highest soybean equivalent yield, minimum energy requirement, maximum gross and net returns, as well as the at part with the treatments T4, that is the soybean plus to soybean pigeon pea strip in 12:12 ratio. So these are some of the photographs in case of soybean as well as pigeon pea. Sole pigeon pea harvesting of soybean is also done by combine harvester. And yes, and I'm very thankful to the organizer that giving me the opportunity to present this project on this in this international conference. I'm very thankful to our honorable vice chancellor also for giving this opportunity. And I think I am only the one of the agronomists which is attending this, participating this internal conference. So with this, thank you very much.
Thank you, Dr. Asiwa. So we still have time. So any question from the floor, please? Okay, Professor Viswanathan, any question?
No, 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 sir. No.
Okay, so if none,
Yeah,
thank you
yeah,
again.
it is appreciable that an agronomist has participated and presented his paper, which has engineering intervention. Which has
Yes, sir. Yes. Thank you, sir. Thank
engineering
you.
intervention, and thank you.
Okay, thank you,
Thank you,
Dr.
sir. Thank you very
Asiman.
much. Yeah.
So shall we move to the next paper? So next paper, number 10. The paper entitled Investigation of Landsat Image to Detect Snow Cover, Debris Cover, and Green Ice Glacier Cover in Nepal, in Kochi, Kandahati, and Kanali Basin. So will be presented by.
I don't know whether the speaker is present. He is from Nepal Society. They have network issue today.
Okay, so there will be no paper this
Presenter
one.
is available.
So shall we move to the next paper?
Yes, yes, sir. If they
Next
join tomorrow,
paper,
we'll give them a platform.
next paper number 11. Anybody here? The paper entitled
Samir
Solar
Shrestha.
Irrigation for Sustainability of Paddy Production and Gender Empowerment from Nepal.
Yeah, he is
Dr.
also
Cheta,
from Nepal. Shrestha.
maybe not available.
Yeah, not available today. Maybe if they join tomorrow, we'll give them in
So
another session.
that's all for this session. Thank you very much for participation in this session. Okay, thank you all.
Much. Thank you very much, sir,
Thank you,
organizing
sir,
this.
for chairing the session.
Okay. Any message from the organizer
Yeah.
for tomorrow?
So on behalf of the organizers, I thank Professor for his present and Vibun Tiban. Thank Vibun Tiban for chairing this session and conducting it very nicely. Those who are not able to join will be given opportunity to join in the other sessions the tomorrow. So now I think we'll break and join again for the session on award ceremony and other sessions. Thank you all.
Okay,
At what
thank
time,
you
sir?
all.
That will start at 3 o'clock.
3 o'clock. Okay.
So,
Okay, sir.
yeah, up
Okay,
to
sir.
2:45
Okay.
this session, and this award ceremony and general body meeting starts at 3 o'clock Indian time and 16:30 Thai time.
Okay, sir. Okay.
Okay.
So 3 o'clock we have
See you
another
tomorrow.
40 minutes. We can join.
Hello.
Hello.
Jonathan,
Sorry. Yes.
Yes.
Yeah. We have. Yeah.
This session is complete.
Yes.
Yeah,
Okay.
we'll
And
close
what we
this.
can do is
Uh,
we will join. This session will be completed today. on this link 1. So link 2, everybody requested to join at 3:05.
Yes,
Okay.
for the award ceremony
Link 2,
and AGM.
everybody join. 3:15
3:05
starts,
and
actually.
3:05.
3:05, let them join because they will take time, 5 minutes.
All right.
Everybody. 3:15 will start the session, actually.
Exactly.
Yeah, please go ahead.
No, I have invited Professor, Honorable Vice Chancellor from Kathmandu University to. Hello.
Yes,
Yes, sir.
go ahead, please.
No,
Yeah, we can hear you.
award ceremony. That session will be joined by Honorable Vice Chancellor of Kathmandu University, and he will give his best wishes and blessings. Successful completion.
Yes. Good. It will be good.
So we'll
Okay.
All right.
So,
You can
Dr.
join
CA,